chapter 4, Math 103. Before we start these sections, first I would like to talk about when you have 2 points. This is in algebra. If you have 2 points, the coordinates of 2 points are given. How would you find the equations? To find the equation, first you find the slope, because each of these points, let's say the first one is x1, y1, the second one is x2, y2. You find the slope, and then you use the equations and take 1 point and a slope and plug into this formula to find the general equation of this straight line. So the line that goes through this is equations. And this is a linear correlations. That means for any value of x that I substitute, any arbitrary number I substitute for x, I always have the y value for it. And all these points, they all lie on one straight line. We have a similar equation in a stat, and they call that regression equations. So regression equation, it's y with a little hat on the top, and these two coefficients, there is a formula for it. So what you have here is your x is predictor variable and y is depend or response variables. So first you find the equations, and then for any value of x that you substitute here, you find your y. Now, how do I find this BO and B1? If you want to do the hand calculation, these are the formulas. For instance, in any problem, we give you a bunch of x and their pairs of y. For instance, if I want to find sum of x, I just add all these, and if I want to find sum of y, I add all these numbers. And in the formula, you also have sum of xy. So you take each x and multiply by each y, and that gives you the value of xy, and then you find the sum. And remember, we don't have to go through the hand calculation if you understand how to apply the calculator. If you use the calculator, you don't have to go through all these calculations. But I just want to show you that regression equations is equation of the straight line or a linear equations. And to find that, you need to have bunch of axes. So if in the x and y axis, if we give you some points, they all have values. Let's say 5, 2, 3, 1, and 4, 3. These are just examples. If you have a bunch of points and you need to find equation of the line that very well fit here, you need to draw a line that very well fit. So all the numbers clustered along that line. That is regression line. Okay, so now that brings us to here that I leave a copy of this so you understand. You go through that. Now, when you plot the points, you might have a situation that all the points are clustered around the straight line, so I can easily fit a line here. You might have a positive or negative slope. And this is a case of nonlinear. See, all the points clustered around this curve. It's a good fit, but it's not a straight line. See, these are not nonlinear. There is a value, they call it coefficient of correlations. This value, if you have a very strong correlations, means the numbers are very close to each other on this straight line, the R is very strong and is positive in this case. Now, if you have a situation that all the points are scattered around and you cannot really fit a good line through it, then there is no relationship. So here, if you have a correlations and direction is this way, going up or climbing, R is positive. If the line is declining, R is negative. Now, you either have 100% correlations, whether it's a positive or negative, or no correlation, which is 0. So when you find the value of R, if R is 0, means there is no correlations between 0.5 and negative 0.5. If your R is a number, let's say like 0.3 or minus 0.2, there is a correlation, but it's not very good ones. If the R value is between 0.5 and 0.8, or minus 0.5 and minus 0.8, there is a correlation, is a moderate correlations. But if your value of the R is beyond 8.8, or 80% to 100%, or negative, because of the different type of slope, then you have a very strong correlations. See, R is 1, R equal 1 or 100% when all the points in the scatter plot fall on the straight line. Like this is a very, very strong correlation. You see all the points lie on one straight line. So if you go this directions, if you're climbing, R is positive 1. If you're declining or the slope is decreasing, then it's negative 1. These are other examples. This is really strong. See all the points, all the pairs are kind of close to this line. So you could actually fit a good line here. This is not a good one. Look, the points are all scattered, so you cannot really fit a very good straight line here. So R actually measure strengths of correlations. So the R value shows linear relationship between two variables of X and Y. Now let's look at some of the example here. Look at this scatter plot here. Does it appear to be a relation between X and Y? Yes, you could easily put a line through it, right? If so, does the relationship appear to be linear? Yes. See, you could easily fit a straight line here, goes through all this. Would you describe the linear relation positive or negative? It's a negative. Remember, when you go this way, it's always positive. When you go this way, it's negative. Ascending or descending also, or climbing or declining. How about this one? It's not a straight line, right? It's kind of like a curve. Does this appear to be a relation between X, Y? Yes, there is. But it's not linear. So in this case, it is a curve. It's not a straight line. So it's not a linear. Would you describe the linear relationship as positive, negative? There doesn't appear to be any linear at all. Now let's look at this one. Does there appear to be a relation between x and y? Yes. See, they are kind of close. If does relationship appear to be linear? Yes, because you could actually fit a line here, goes through this. Would you describe the linear relationship as a positive or negative? We're going this way, right? Going up, so it's positive. Also, you could fit a line here. See? So, there is a relationship. Is it linear? It's positive. Okay, so you could see a copy of this all online. All right, now. So the paper relationship between cell phone and academic performance anxiety, so you could read this. R is minus 0.2.03, somewhere here. Okay. First of all, when it's negative, then coefficient is negative, and it shows that it's lower, right? Because remember, it is also very weak. So that minus 0.1, minus 0.1 fall here. So they're asking about this value R. This is a very small one. Remember, when you have the R between, and R is between 0.5 and minus 0.5 is very small. This one is minus 0.1. And here I show you that, show the relationship between text sent and text received is going into the positive directions. Cell phone use and GPA is opposite directions, means is declining. The more cell phone use, the less GPA. These are some multiple choices that you could actually read it. You know, like weight of the car and gas mileage. There is a negative correlation because heavier cars tend to get a lower gas mileage. Or here, selling price of the house. There is a positive correlation because larger house obviously is more expensive. Height and weight. Positive correlations because taller people tend to be heavier. Height and number of siblings. There is a correlation close to zero because there is no reason to believe that height and number of siblings are related to each other. So these are some of the multiple choice that shows you the difference between two variables. All right, now, so let's look at this problem. So the best way to find the R value, okay, first of all, the value of R is, if I read the problem first, and let me see if I can find the R value for you. To find the R value first, you need to, you could either use the formula, which I mentioned is a long formula. Or you could go ahead and input all these numbers in L1 and L2, and then find the value. So here, again, it's easier to use the calculator for it. So let's go ahead and put all these numbers. Let me see if I have it in any of the calculator here. I have some numbers already, so I have to erase those. So you just say, you go to Stat, and I want to clear all the lists that I have in L1 and L2. Okay, and then we just go ahead and put the stat again. We put all the numbers in L1. So L1 is 6.72, 7.07, 6.97, 6.69, 6.19, 5.58, 5.13, 4.95, 4.74, 4.59, all right, so now we put the second one, 5.98, 5.97, 5.86, 5.60, 5.15, 5.06, 4.98, 5.22, 5.30, and 5.45. So we should have 11 numbers, 10 numbers. So we are waiting for number 11. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now you go to Start. And scroll to the right for the test. Go to the almost the very last one, which is this one. F, linear regression t-test. Calculator already has L1 and L2. If you have your number listed in L3, L4, or other one, you could just put that. So you don't have to do anything here. All you need to do is just verify that your X is in L1 and Y is in L2. Just go straight to calculations. So here, what you see as far as the A, see A is 3.81. And B is 0.28 almost. And R2, R is 0.72. Okay. So the formula, if we ask you to find regression equations, if you recall, regression equation was A plus BX, right? See, they have it here as A plus BX. So Y is 3.81 plus, that's how to find regression equations. R value is 0.72. And we know 0.72 is here. So it's a moderate correlations. Okay, 0.72 is somewhere here. Now, first they want you to calculate that. Now they want you to plot it. So to plot it, first you want to make sure you go to the second, see under Y is a stat plot. You see that the stat plot is under Y. So you go to the second stat plot. Make sure the first one is on, plot is on. So when you enter, change it to on. And then the scatter plot could be the first one. And it shows you all the information in L1 and L2, okay? If you, so you have everything. Now you go to graph. Okay, hold on. You see, this is not what you want. The reason is this. So you go to, let's delete everything, and this is a graph I already had from my college algebra class. Let's just delete that. Okay, so we don't have anything there. Okay. Now, it shows, to have a better look, let's go to zoom. Go to zoom stat, so you have a better graph here. You see that? Okay, so when you graph it, go to zoom. Zoom stat is very important if it's not very clear to you. Does it look like this or not? You see that? That's how you can tell which graph is correct. Okay, so I go through the whole thing because this is what we use basically for most of the problems in these sections. So first you go to stat, you go to edit, you put your information in L1 and L2, okay? Then you go to stat again, go all the way to test, and then scroll down to linear regression test. Okay, everything is okay there. And then you do the calculations. That's, you find your A, B. Now, you see that S? You want to use this later on. Let's just make a note of that here. I'll show you where we use it later on. Okay, hold on. On this one, we also have the S is 0.275. And also the R2, we need R2 as well, which is 0.52. Okay, let's keep this 2 in mind. But anyway, the regression equations is A plus Bx. They didn't ask for it, but for some problem we do ask for regression equation. So that's how you find it. And the R value, you find it from here. Okay, and then you need to graph it. Again, to graph, go to second, stat plot, make sure it's on. Everything else is fine. Make sure it's on the first one. Then you go and graph it. And if the graph is not good, go to zoom and zoom stat. All right, okay. So the rest of these problems are very similar to those. Section 4.2. I just go through these very quick because they all are very, very similar. So this would be a good practice that you have the solution for these problems that you could practice yourself. Although your version might be different. Okay, this is another one very similar to that. I Pick this because it has less numbers. Okay, this one I already input into here. Look, this T84 calculator. You have all these numbers. Okay, so now you go to stat again, go to test. Everything is fine here. Calculate. They give you all the value that you need, A, B. You have A, B, S, R. You have all the numbers. Now you want to graph it. First, you go to second. Make sure it's on, is off. You see that? The first plot is on. You need to have one of the plot on. So enter. Go to on. And it's the first one. I think the second one might be okay too. Well, let's just try to see how it goes with the second one. Okay, go to graph. It's not clear, go to zoom. See, in this one, why there is a graph? Because there is, y is not m. So go to y, see that y? I have equation, let's delete that from my other classes. Okay, so you don't have anything because the calculator understands a bunch of graphs at the same time. So there's nothing here. Okay, so go to graph now, go to zoom. Zoom is that. It should give you all these numbers, and I don't know why it's connected like that. Let's try to see what happens. Let's go to Y again. Oh, okay. So on a stat plot, let's not pick that. Let's pick the first one, okay? Remember how we pick the first one always? Okay. Yeah, because that's what we selected first. You don't want that. You want the first one. Okay. Now we're going to graph. Now it's better. Okay. And that's the one. Okay. So as I said, these problems are all very similar. And I wrote the equation for you here. I turn this page is quick because I'm going to leave a copy of that online for you to see. And this is another one that, you know, when you have a bunch of points, and I made a note here. You know, we start having some points. We give you some points in the problem, right? You plot all these points. And then based on that, you come up with the equations. But then if we throw another number for x, how do we know this equation is, you know, is a good equation that you could predict a new number? So what it is, let's say if we give you a number, you put that number here. We take one of these x to see if we get exact y or not. Obviously not, because when you have bunch of points, and you fit a line and you come up with the equations. So that means any value of x you substitute here, you have always value of y, right? But let's say there is a point that we already know it was like 3.7. Now, this line is the best fit, But it doesn't mean that if you substitute 3 here, it would get exactly 7. Okay, it might get the number closer, but it may not give you exact 1 because this is just the best fit. It's not like when you have this situation, look. This is 100%. Yes, any of these x that you have here, if I write the equation for this and take one of these numbers for the x and substitute here, then it should give you exactly that because this is a perfect 100% line. But when the numbers are all clustered and we are able to come up with the equations, this equation doesn't mean that for this particular x you get exactly that 7. Okay, so there might be a difference here when the situation like that happens. So this is the value of the y that we originally have. This is a value of the y that you have from the equation. So there is a difference between these two. So if I take the same x, let's say if I take one of these x and substitute in the equation, it might give me a different y. Difference of these two is what you have here. They call it residual. Residual means when you find deviation. I'll show you on this example. Okay. Residual is the y that you observe, given the problems, minus y that you find through the calculations. That's the residual value. I'll show you on this example here. So if you want to look for residual line, the x is the same, but the difference of the y would be the new y value. Now, where do we use this? Well, obviously, the calculator would give you these two values of S, standard deviations of the sample, and R2, right? We find these two through the calculator. What they do is, it's not enough to look at just R2 or just SE when evaluating the deviation line. Remember to consider both values. In general, you would like to have a small deviation and large R2, okay? So when you have the new points versus the old points, you want to have less deviation from the line. So you want to have a smaller standard deviation, but larger R. Why? Because if R is getting close to 1 or R is greater than 0.8, is a stronger R. You need a good, the larger R indicate a very good strength on correlations, and smaller standard deviation is good because it shows you that the numbers from the original ones are not much deviated. So that's one thing we need on the next sections, remember, okay? This one, what I did, I took all these numbers in L1 and all these numbers in L2, then I find all these ones, R2 and S, you see that? This is a standard deviation of this sample, and this is the R2 is 0.279. And these are what you have here. The R that you calculated in the problem was 0.5. So remember, between 0.5 and 0.8 is a moderate. This is another example I'll show you here. I'll put, see, these are easier because they don't have that many lines. 4, and these are L2. Again, you go to the same calculations. Show you how to do the stat plot. As I said, these problems are all very, very similar. You know, I have the calculation for some of you. Okay, so that would be basically what they cover in chapter 4.